Alicia, good morning. Good morning, Anthony. Good morning, Errol. And Chelsea, good morning. Yeah, and I know our seniors will not be here today because they all have a clausura in English. So we'll wish them well mentally. And we'll continue with acid-base stuff. We're going to review a little bit first and then see how far we get. Others are arriving too. Go ahead and say hello. It's Penelope. Good morning, Penelope. And I should have two more. There's Bella. Hello, Bella. And there's Lola. Super. Seven. Okay, a couple more and then we'll start up. And while you're waiting for others here, go ahead and look at this. HNO2 plus Br minus makes HBr and NO2 minus. Maybe you can tell me which ones, for each conjugate pair, tell me the acid and the base. How about I say it that way? For each conjugate pair, tell me the acid or the base. Okay? So we'll do that to warm up. Anybody else there? Say hello if you are there. I got a couple of you maybe have not done so yet. Okay, then let's go ahead and begin with our warm-up problem. So give me the two that go together, the conjugate pair, and tell me which one's the acid, which one's the base, if you would, please. I'll read it again in case I'm pixely. Oh, some of you are there already. So I got HNO2 plus Br minus makes HBr plus NO2 minus. And I got a couple of answers already. Super. I'm going to underline. Actually, I'm going to write underneath what people said. So there's one from Errol and Bella, and they got that one already. They did the pair with HNO2. They called this an acid, and this the base. And that's right, and that's one conjugate pair. So that's what we call it, conjugate pair. And let's see if somebody else got the other one here too. Miss Chelsea does. So she says this one, Br minus, is the base. I'll tell you what, let's do that in blue. She is right. And this sucker over here, she has as the acid. And there's another conjugate pair. Okay, I'll just write that. I don't have to write conjugate pair again. You know that. Good. And Sophie, super. Thank you for checking in. I'm up to 8, and a few seniors are not here, although I expect another couple people. Let's see if anybody else snuck in that I didn't see. I should have one or two more. If you haven't said hello, please do so. I got most of you. I've got Alicia, Anthony, Errol. I got Chelsea, Penelope, Bella. I got Lola and Anne Sophie. Okie dokie. So this is 8 to 8:30. Good. So if you got questions on that, let me know. But let's go ahead and start up. So, my people, I have a serious question for you because I never see you. I don't physically see you maybe till March 9th. And my question is very seriously, how are you doing on the book? Is it going well, or are you frustrated and can't do it? You're not asking many questions. I'm going to take questions again today, but this disturbs me. I've never had a class not ask questions. I have to know. Are you getting this? Are you finding it okay? Or are you simply not getting it and are afraid to ask questions? Give me a little feedback here, folks. Is it easy? Is it hard? Are you way behind? Are you way ahead? Okay, good. All right, thanks. And we'll take your question in just a sec, Alicia. Let me get some feedback from others and see. The class is working slower than the pace I can handle through the book. I'm still on chapter 3. That's fine, Bella. That's fine. Okay, and Antonine's not getting as much progress as normal school, all right? Bella, are you saying that when we're in school, you do stuff at a faster rate? Is that what you're saying? And others, kind of the same. Okay, but I want to make sure I understand what you mean by kind of the same. So, for each of you, are you going quickly or slowly through the material? um, and if you're going slowly, what is stopping you from asking me questions? So what is the difficulty here with you asking me questions? Okay, I'm reading some more feedback. Yeah, things are a lot easier to understand in person. Thanks, Anne Sophie. I agree. I agree. You may have to go back and look at my videos a second or third time, by the way, and you can certainly do that. Yeah, we're getting through the book faster. Now, Bella, bear in mind, when I go through the book faster, it's because I want to stay ahead of you so that when you get assigned a new chapter, we've already talked about it. So I'm doing that on purpose. I want to be a chapter ahead of you. I'm not doing this to stress you out. I'm doing it so I can introduce the material to you before you get to it in the book. So, I'm trying to remain flexible also with my deadlines and whatnot with you as well. But on the other hand, we got to finish up by beginning of April. Really, that's kind of our goal. Let's see what else you have to say. I am interested in your feedback, people. Okay, Lola, thank you. Feel like trying to understand a CO. Antonina, you'll have to explain that a little bit more. I don't get the abbreviation. Thank you, Chelsea. So it's a little slower progress for you. Okay, and you're feeling behind, Bella. All right. Trying to understand a concept while working through a different one in the book can be very challenging. Yes, Antonine. I developed this concept a few years ago, and it was the suggestion of students because they found that if I didn't get to something first, they felt really frustrated seeing it for the first time ever just by reading it in the book. So I have decided it's better if I talk to you about things ahead of time, even though, Antonina, I know it makes it then two different subjects you're thinking about. But it'll be that way in college too. I hate to tell you. You'll be working on one assignment and the prof will be talking about the new material. So same thing there. Okay. So Bella's saying maybe the fact that I can't grade the books is disturbing you because you feel like, oh, maybe what's the use, huh? And I wish I could. I wish I could. I will grade them, but obviously I can't right now. So we'll try and figure out a lab or something someday when I see you. I hope in March, and then I can gather the books and grade at least one chapter, maybe while you're doing the lab. Okay. Well, I want to make one comment, and you can keep writing, but I want to make a comment before I forget. Okay. Okay. My comment is this. I've assigned an AP classroom quiz for this week. A few of you didn't do the last one. That's an expensive zero. Don't not do this one. This one is on chapter 1 in the second book, which all of you are through. So go back and review the concepts a little bit and take that online quiz, please. I'll grade it with the AP Clausur scale, so an easier scale. But if you don't do it, I have to give you a zero, and you don't want that, and I don't want to give you that. So please do it. I think it's by Friday, okay? So that's review chapter 1 and do that. But I purposefully picked a chapter that I figured you'd really be done with, okay? All right. Okay, let me see if there's any other comments before we start up. Okay, that seems to be it for things you want to tell me. Okay, then let's go back and pick up your questions. Let's make it questions on chapter 3 or 4. So let's see what you'd like to ask about chapter 3 or 4. I know Alicia has one, and let's see if some others of you do as well. Mark the pages, okay? Just fold the pages on any you have questions on. I want to help you. I want you to do your best in this course. I really do. And we're missing a couple of juniors here. Most annoying. Oh, I got a couple questions. Good. I like it. I like it. Okay, so let's do the one on. Let's do the one from Alicia first, just because I saw that first. So page 244, number 2. Great. And then we'll get the other ones from Bella. Okay. Okay, so everybody turn to 244, number 2. And let me double check. Yes, that's the one. Okay, it says a student prepares a saturated solution by dissolving 5.5 times 10 negative fifth moles of MgOH2 in 500 milliliters. Get the KP. Okay, find KSP. Okay, here we go. So the deal is, for this solubility stuff, you start all the problems the same. What you do is you take it as a solid, MgOH2 in this case, and show the sucker breaking up into parts. show it dissociating, right? Falling apart. So I got it Mg2 plus 2 OH minus. Okay, then you got to play the S game. S for solubility. Well, let's do just the regular game. Okay, let me see if you're awake this morning. I got one of these. I get one Mg2 plus and, yeah, two of these, two OH minuses when it breaks up. Now let's say I have S of these break up. How many Mg2 pluses do I get? You can just type in two answers. How many OH minuses do I get? If I have S of these dissolve or dissociate, how many Mg2 pluses, how many OH minuses? Just so I know you're following. Good, thank you, Bella. So I need S of those, or I get S of those, right? And the OH minuses, maybe we'll see if somebody else gets that one. No, that's not right, Anne Sophie. It's 5.5 times 10 negative fifth. I just looked again on page 244. Okay, and 2S. Thank you, Chelsea and Alicia and Errol. That's correct. Here's why that's so important, okay? And I know you're saying, Mr. Weiss, you're ignoring all the numbers. I am. We'll come back to the numbers. We'll come back to the numbers, all right? So here we go. The KSP is, remember this guy's a solid, so I don't care about that. So I got Mg2 plus concentration times the OH minus concentration squared, right? Because it's got a 2 there. Okay, now drop in the S. So for in terms of S, and look, this is what we're trying to find the problem. We want to find the KSP. So in terms of S, it's 1S times 2S quantity squared. So I got to go S, that's for the Mg2 plus, and then for the OH minus, it's 2S. But then you got to square that. So it's like you use the 2 twice. So algebraically, it's 2 squared is 4, 4s squared times another s, 4s cubed. Now you can use the numbers. All right, so here we go. For the numbers, it's relatively easy. It's a saturated solution, so that means you got S. So S is in moles per liter. And up here we can say, oh, well, look, it's 5.5 times 10 negative fifth moles divided by half a liter. So 0.500 with significant figures, liters, whatever that gives you is S, okay? And once you get that, gang, put it in here and I'll let you finish the rest, right? So write that down and let's see. And Bella has a question about the reactants. Do they go into the denominator? Well, here's the deal. If we're talking solubility solid, it's always a chunk of solid and I put it in a beaker. But you know what? If it's a solid going to aqueous plus aqueous, remember, Bella and everybody, solids are not in an EQ or equilibrium constant expression. So it'll just be, I'll write KSP, although I can write KEQ or K whatever. So it's just the product. So it's like my first one times the second one, sometimes 1 power. It's a product of those divided by nothing because the solid will not be included in that. So that's why it's called, you ready? Da-da-da-da. It's called a solubility product. It's only multiplying a couple things together. That's why it's a product, because there's nothing to divide by, because you start with a solid every time. So product, multiplication only. No division. Yes, yes? Let's see if we have other questions about this. I think that'll get you there, Alicia. So I think I'm going to go to a Bella question next. Okay, so she has two. I'm going to take the first one from her. Page 202, number 7. I'll write it over here, and then I got to erase in a moment. Page 202, number 7. You know what, Bella, let me put your other one up here, too, before it gets lost here. Page 207, number 1. But we'll do 202 first. Okay. Any other questions on this? Good. Okay, then let's go to page 202. Page 202. All right, I'm going to erase this in a sec. Let me get to page 202 first. Here we go. Good. Okay, I got to take this off here, gang. Good. Okay, so number 7 says, considering the following reaction, I got 203, called ozone, by the way, going to probably what? 302, right? 302, and they're both gases. And the delta H is negative 285.4 kilojoules per mole. And I think it means per the way the reaction's written. Let's take a look, Bella. I understand your question. Let's have a look. And she says she's mainly after part number B. Okay. I'm going to look at A first. Predict the signs for delta S. Okay, so for delta S, I want to do A with you anyway, okay? So don't panic. We're going to get to B, Bella. But let's do A first. Let's look at delta S, gang. I got 2 moles of gas going to 3 moles of gas. Is it getting more or less random? 2 moles of gas going to 3 moles of gas. Am I increasing or decreasing the amount of entropy, disorder? What do you think? 2 moles of gas to 3. Am I increasing or decreasing disorder? More random, right, Bella? More entropy, right. And if it is, we're going to make that a positive. So I'm going to say more gas, more moles of gas. So delta S is positive. Yeah? Everybody got how we got that? Just by thinking, right? 3 is more moles than 2. So it's more moles, it's more random, more entropy. And more entropy is positive then. Okay? That's the one where if it's crazy or if it's more disordered, it's positive. Okay. For the next one, and this might answer your question for the next part too, Bella. To get the delta H sign, delta G sign, I got to use the equation, I think. Delta H minus T delta S. Remember, T is the temperature. So, my people, if this is negative, and the entropy is positive. Oh, but check this out. I got a minus in the equation, so I got negative and negative. So gang, let's see if you can figure out the math. What's the sign have to be on delta G? So delta G has got to be what sign? We don't need the amount yet, we need the sign. Must be negative, positive, increasing. Let's see. I think it's got to be negative, gang, because it's a minus, and then another minus because this is just positive. So it's just going to be a lot of negative. Okay? I think it's got to be negative. That's part A. Let's do B. For B, it says we got to use the values in A8 to get delta H, delta S, and delta G. Okay, so appendix 8. On the AP and on my clausura, I will give you that data. But you have to look it up here, okay? So let's do the delta S. You ready? Here we go. Delta S equals S of the products minus S of the reactants. S of the products, here I got to get back here, huh? There's a. Okay, what do I got here? They only got one product and it's O2. Paging, Mr. O2. Hello, O2, here it is. The delta, the entropy, holy, here, let's put a marker here to hold that spot. The entropy for O2 is, and stop me if I get the wrong one, I got 205.14 joules. 205.14 joules, probably per like mole Kelvin. But gang, I got what? I got 3 moles there, right? So that one multiplied by 3. And then minus the reactants. Okay, so it's O3, so minus ozone, and I get 238.93. 238.93 joules per mole Kelvin. And I got to multiply that sucker by 2, which I did here before I forgot and ran out of room. So I got 2 moles of that. So, Bella, that should get you the delta S. Voila. You got delta H. Voila. And here's what they want you to do, Bella. Okay, they want you to do this. Yeah, they want you to use 2 methods. Yes. Let me go back now to the question. Okay, you ready? All right, so we're going to do, so get delta G 2 ways. This is what I think they want you to do, and compare. When you get the 2 answers, Bella, they should be pretty close. So let's do the first way. So the first way is to use my favorite equation in the book, which is this sucker. And I'm going to just put a line because we're going to use that right next to it. And I'm going to say delta G equals. Okay, now, be careful. All right. I got this in kilojoules per mole. The other sucker's in joules. Do they do that on purpose? I don't know, but I hate it. Every book I've ever used does that. You got to get them in the same label. We probably want kilojoules at the end of the day. So I got negative 285.4 kilojoules per mole minus T. Well, I think it's standard, so it's 25, so 298 Kelvin, right? 273 plus 25. And then whatever you get for your delta S, put it in here. But it's got to be in kilojoules. So that's going to, so ding, ding, ding. Okay. Achtung. It's your delta S in kilojoules. So you'll have to divide by 1,000 to get it in there, right? Anyway, Bella and everybody else get an answer. Delta G equals blah, blah. Okay, then, so that's one way. The second way is you're going to go delta G equals G of the products minus G of the reactants. G of the products minus, those are not sixes, they're G's. G of the products minus G of the reactants. And we got to get that from the back of the book again, table A8. So there it is for O2. Well, that's nice, it's 0. And for O3, it's not 0. So I'm going to just let you fill that in, okay? Because you can do that as well as I. Ba-da-ba minus ba-da-ba-da-ba. So the product is O2. I think that's 0. You know, I'll put in the 1 for you. Yeah, that's 0. 0 minus 2 times whatever it is for O3, right? And then you got to sort of say this, fella. Are they the same or similar? Hopefully the answer is yes. So Bella, I think that's how you can finish it up. I think that's what they want you to do. So get it 2 different ways, compare and say, yes, it worked either way. And by the way, they're doing that so you understand that there are 2 ways to get delta G. That's the goal of the problem, is for you to understand that once you're done. Let's see if there's any other things that you or others say that I need. You're welcome. I hope that helps everybody on that if you're there or whenever you get to it. Okay? I'm going to erase this in a second, so let's see if you got any questions before I do, and then we're going to do the second one that Bella suggested on page 207. I'll look at that while you're thinking, and also I'll erase everything when you're done. Okay. Ole preole. Okay. Yeah. Okay. All right. Then I hope we're ready to erase. Here we go. So I hate to lose that page in my 1 meter studio here. Okay. So let's go to page 207. Number 1. And it says, get the Gibbs free energy from this equation, N2, it's to make ammonia, plus 3H2 forms 2NH3. I'm going to just say all gases. I don't have to write the little G's and make it even more confusing. Now, if the pressure of all three gases is 2 atmospheres and the temperature is 23 degrees Celsius. Okay, they give you a good hint here. It says begin by getting delta G using the reference values and then blah, blah, blah. Okay, so let's first get delta G standard. Ready? Just like the last problem. It's G of the products minus G of the reactants. Okay, so you got to look them up. So we're going to look them up. Here we go. My product is NH3 gas. I'm looking, and it should be by the ends. Here we go. Here it is, the NH3 gas. I got negative 16.45 kilojoules. Per mole. Okay, times, you guessed it, Chester, 2 moles. Right? 2 moles. Minus, I'm going to put brackets because I got 2 different reactants. All right, N2, there it is. Well, it's 0. Well, that's nice. Hallelujah, brother. And then I got 3 moles of H2. H2. I don't like the way they have this data arranged. Flipping A. Where's the dang hydrogen? There it is. Oh, well, that's nice too. It's 0. Well, thank goodness for small favors, huh? So that's kind of cute. So the delta G, we can do that mentally, can't we? So the standard delta G is just double this sucker. So we got what? Negative 32.90. Is that right? Can you check my math? But we're not done with the problem. The problem says they want it at non-standard conditions. So we got to use the famous equation, the correction equation, that has to do with Q. Ready? Q to U. Here we go. So I want a new delta G. So it's the delta G standard, and this is from page 205. So it's the delta G standard plus RT times Q. No, times, it's all right, times the natural log of Q. Okie dokie. All right, well, we know what this is. So delta G is this delta G minus, and everybody get that? Thank you, Bella. That's correct. Okay, good for checking. So it's minus 32.90 plus RT. Well, the R I got to look on. I'm pretty sure I want it in I want it in kilojoules. So I got to go 8.31 times 10 to the negative third kilojoules per mole Kelvin. Okay. Chelsea, Alicia, and others, have I done that correctly? Is that the right R value? So 8.31 times 10 negative third. Is that right? Please check me. Now, gang, it says they want it in this one Bella asked about at 23 degrees C. So I got to change the temperature. It's not 298. 23 plus 273. Well, that's nice. It's 300. 300 point. Okay. Finally, it's times the natural log of Q. Now, to save time, I'm going to write this in the problem. You ready? So natural log of Q, remember, Q is just K with not at equilibrium. So it's products over reactants, right? Okay, Q, products over reactants. So my product, I only got one. It's 2 of NH3 gas. Now it says if the pressure of all 3 gases is 2 atmosphere, hallelujah, that's in the correct unit. I need it in 2 atmospheres. So I'm going to go pressure of this guy, so 2 atmospheres. And that I need 2, so I got to square that, right? Divided by, well, these are both 2 atmospheres too, so I got to go 2 atmospheres. That's for the N2 times, remember it's not plus, it's multiplied, okay? In the KEQ expression, plus becomes multiplication in the expression. So, and that's 2 atmospheres as well. 2 atmospheres times, to the, what? A third power, right? Well, the nice thing is they're kind of cute, aren't they? Because you get rid of some atmospheres, don't you? Like some of these cancel out. So I get 2 of these. So I got basically 2 times 2 at the bottom, which is, I think, 4, right? So 1/4. Anyway, you can do the rest. You can do the rest, right? Do the rest. See if you get the right value. Okay. How did you get the R value? The R value, Anne-Sophie, she gives it on page 205. She gives it in joules, but we need it in kilojoules. So what I did is, thanks you, Alicia, she says I have it right. I got to take the 3, on page 205, Anne-Sophie, towards the top of the page. R is 8.31 joules per mole Kelvin. But I got to divide it by 1,000. So it's 8.31 times 10 to the negative third kilojoules per mole Kelvin. And yes, you'll have to be able to do that. All right, and Anne-Sophie caught me, didn't she? So it's not 300. Thank you, Anne-Sophie. That's why I keep all you guys around, to catch all my many mistakes. All right, so it is what, 23, and she's right. 23 plus 273 is not 300. Bad, teacher. Thank you, Anne-Sophie. So it's 296. Please correct that mistake. Pleasantly found by Anne-Sophie, and maybe some others too. Thank you very much. Okay, that should give you the right answer now. Sorry about that. Good. Does that help, Bella? Will that get you there? And if so, my people, are there other questions that you'd like to ask about in chapters, I don't know, 3 or 4, let's say. 3 or 4. You're welcome. Anything else in 3 or 4? Do what these folks did. Mark them and then be ready to ask me. You're not out there alone. I don't want you to feel alone. And maybe that's why you feel frustrated and you're going slow. If you don't get it, mark it. Ask me. If we don't have time in class, write me an email. As those of you that have done that have found out, I respond and I talk to you about how to do a problem. Okay? You're my most important class. You're my most important people. I want you to feel empowered. I want you to feel like you can have some success even at home. If you don't get it, ask me or write me. Okay? Okay? I love you guys. I want you to do well. You're my best class. Okay? So take responsibility and tell me what you don't know if you need help. Because that's why I'm here. Okay? In my little basement. Okay, question about the formula. Okay, so it's this. I've got to do R times the temperature times that whole natural log of Q. So Bella, get the natural log of this whole thing. So it ends up being, I think, 1/4. Take the natural log of that, multiply that number times 296 times 8.31 times 10 negative third, get a new number, and add that to, I got sloppy here, negative 32.90 kilojoules per mole. Sorry, I got sloppy. And then you should achieve some success. We have tutor sessions. That's kind of what these are. And Sophie, let's use the first part of each hour as a tutor session. I'm happy to help you, but I don't really want to do it one-on-one because there's 15 of you. I'd much rather do, because if you have a question, one of you, a lot of times other people have the same question. I know you've heard that many times in your life, but it's true. So I want to help you, and it's good if we work together. Because sometimes I screw up, and then one of you catches my error like Anne-Sophie did today. And that's why it's really good for us to work as a team on these days when we're meeting. Okay? All right. And as you probably remember from first semester when we met live, if there are days when we have a lot of questions, I will spend time on questions, and that's what we're doing today. Other questions I can help you with, please ask now. And my question is, where's my eraser thing? How can I lose something? My studio is 1 square meter. That's not even possible. How embarrassing. Yeah, look at that. You ever lose something in 1 square meter? It's a little pathetic. You're getting senile. Okay, anything else on this? That's the right answer and it worked. Yes, good, Bella. Okay, good. Glad to hear it. See, little successes. That's what we're going for. Step by step by step. Anybody else? Any ones you want to ask about? Now's your opportunity. Now's your opportunity. While you're thinking, I'm going to look ahead. All right, so I want to see where we got to last time. 282. I think I want to review something. Okay. All right, I'm going to do a little more in acids and bases, but I want to ask a review question and just see. Okay, so I'm on page 277 where I got a bunch of data. I want to see if you're thinking this morning, okay? Okay, which acid dissociates better or more? Benzoic or boric? Okay, can you look at that data chart, everybody, page 277, and find benzoic and find boric and see if you can answer my question. Which one dissociates better? Look at the numbers and think about what we said last time. Which one dissociates better, benzoic or boric? Page 277, which is a better dissociator, benzoic or boric? Still waiting for your answers. Try and find them both. Look at the names. You'll find them. All right, Earth 2 class. We're mighty slow. So either the connection's slow or we're not thinking so good. Let me give you the Ka's, okay? Here's the Ka for benzoic. Because, of course, that should help you. 6.5 times 10 negative fifth. Here's the Ka for boric. 7.3 times 10 to the negative 10. Hey, now I get some answers. And they're right. Thank you, Lola. Thanks, Anne-Sophie. Thanks, Chelsea. Yeah, so this one is the one that dissociates better. How would you know without the, well, they'd give you the data. You got to look up the Ka. So if this is negative fifth, check out this power. That's way bigger number than negative 10th. That's like way out there, okay? So bigger Ka. Bigger Ka equals several things. It dissociates better. And, okay, it's a stronger acid. You will have the data, or you'll have to be able to get the data to answer that. Thanks, all of you, Lola, Chelsea, Alicia, and Sophie, for participating. Appreciate it. Let me know that you're out there, okay? Huge. Okay. Here's a little factoid from I'm up to page 282 now. But it's an important little factoid, and it will make perfect sense to you now, okay? And it says this: equilibrium favors the reaction of the stronger acid I'm going to change her wording because I like it this way better. Dissociating. Let's do one. You ready? Why, let's do one with benzoic and boric acid. We already know which one is stronger. Okay, I'm going to try and make it a little tricky for you. Here we go. Example. H3BO3 plus, ooh, it's big, man, C6H5 COO minus. Yes, they do write it that way. OO. Double arrows goes to, make sure they just take off one. They do, they're playing nice. Goes to H2BO3 minus plus H C6H5 COO. Okay, and the question is, which side is favored? And the answer is going to be reactants or products, okay? Which side is favored? Now, let's look at our little helpful hint. Ready? All right, it's going to be favored the direction of the stronger acid dissociating. Dissociating. Well, let's look at our acids, right? So check this out. There's H3BO3, but there's H2BO3 minus. Okay, so I bet you know which one is the acid. And this, I got C6H5COO minus, and here I got H, C6H5COO. So I bet you know which is the acid there. And one of those is benzoic and one is boric. Well, it's pretty clear which one is boric, right? It's got the B's in it. The other one is then benzoic. And you know which one is stronger. So which side is the stronger one breaking up on? Is it breaking up going forward or going reverse? Is it breaking up going towards the products or reactants? The stronger acid dissociating is what is favored. Yes, good. I got one answer. Let's find the stronger acid and circle it. Well, that's boric. That's not strong. That's the -10. Whew. Now here's the benzoic. Benzoic, that sucker out here. Oh, that's stronger. Stronger. So it's got to go towards the side to dissociate. The side to dissociate. Beautiful. Thank you. Good. Forward is breaking up. Well, what is it, Bella? The stronger one is this one. So there's the stronger acid right there. So I want to make this one dissociate, my stronger one. Okay? I want to make that one dissociate. Good. Thank you all. Good. Thank you, everybody. Right. Lola's got it. Alicia and Sophie. Yeah, exactly. Okay, so here's what that means. So I can make my arrows different too, just to be really snazzy. So it's definitely going to go towards the reactants more. I'll make that arrow bigger, or I can just say it down here. So reactant side. Or you can also say it like I think Lola did, and that is you can say the reactant side is favored. That would be the reverse reaction, which, yes, is another way you can say it. Reverse reaction is also favored. So I wrote down here, reactant side is favored, or you can say the reverse reaction is favored. Yes, yes? And remember, how can I know this? I can look up the KAs and find the two numbers and compare them. You'll have the data, whether it's on the AP or the clausur or a quiz or whatever. You have to have the KA data to compare them. You will always be able to get it. Questions on that? Okay, let me see if I can make a question for you now. Okay. Let's see, do I want to do this yet? I'm thinking out loud, sorry. I'm going to draw a little arrow. and I'm going to ask you a new question. What's the K for this reaction? You're going to like this, but hang tight with me, okay? Hang tight with me. Remember, this reaction, the one where I've got boric acid going this way and the benzoic going the other way, but I got it written as boric acid going forward. So what we do is we say the reaction as written, the K is equal to the Ka of the forward reaction, divided by the Ka of the one going the opposite way, which is, we're going to call it the reverse reaction. But if you think about it, that's not that hard. We just looked them up. Although, like a dummy, I erased them. So let me look them up again. Dagnabbit. The boric one was the forward one, right? That one's breaking up as I go forward. So I got to put that on top. Let's find Mr. Boric. 7.3 times 10 to the negative 10th divided by, well, the reverse one is the benzoic. So that's the 6.5 times 10 negative 5th. Equals. We can kind of estimate that, can't we? You math folks can probably do it. The values cancel. I'm going to get something times 10 to the negative 5th. And it's going to be what? 7 divided by 6, pretty close to 1. So 1 point something. You guys can crank that out, okay? So what is it for me? Could you do that? So 7.6 divided by 6.5, 1 point something, and then times 10. I think it's the negative 5th. Check my math, please. This could be a beautiful multiple choice question. Will they expect you to do this rounding mentally? Yep. So could you get me an answer, folks? Could you punch that in real quick and find the last decimal for me? And then we can go on. Thank you. And Sophie's got 1.12. So round that to 1.1. Let's see if others get the same thing. 1.1 times 10 negative 5th. Yes, yes. No, no. Looking for a yes, yes from the crowd. Alicia got 1.1 as well. Thank you, Alicia. Good. Okay, so that appears to be it. Yeah, so the way it's written is not very likely, is it? That's why the number is so low. Is it going to go that way? No, it's going to go reverse. You told me that already. So to go forward is very unlikely. That's why the number is small. What about if I wrote it the other way? What would I do with these two numbers? What if I wrote the reaction the opposite way? Ready? I would just do what with these two numbers, gang? What would I do if I flip the reaction around? What will I do with my two Ka values? Okay, so I want to write the reaction in reverse. Then what happens with my Ka values? What do I have to do with them? No, you don't make it positive. No. You don't change the values. The numbers are still the same. That's the same and that's the same. But if I write this backwards, what do I have to do with these two numbers? It's not a big deal, gang. Maybe I should do that. Are we a little sleepy? Like me, losing my eraser thing every single damn time? There it is. Okay, and Alicia's got it. And reciprocal. Good, and Sophie, right. So take the reciprocal of this, or just switch the two numbers. So instead of 7.3 times 10 to the negative 10th over this, flip it around. So it'd be 6.5 times 10 to the negative 5th divided by 7.3 times. And of course, then it would be like to the positive fifth power, wouldn't it? So if I wrote it backwards, then if I flip it around, it'll be very likely to happen, very positive. So to be a K that looks like this, yeah, products. Right now, the way I wrote it, it's a K that is no reactants. It ain't going to go forward. Too small. Thank you, Chelsea, as well. Okay, questions from you. That's a trick that's worth knowing. Trick that's worth knowing. Okay. All right. We're up to 5.3. The ionization of water. Now, you and I have kind of talked about this, so this is good. So I hope it'll be fairly understandable. We're just going to start it right now and then continue with it another day. Kind of goes like this. Most water remains water. Does that sound stupid or what? However, a few waters do this. So here's the big but. But a few waters will do this little reaction. Okay, so I got a water plus a water, H2O liquid plus an H2O liquid. And then what they do is one of them grabs an H plus from the other and leaves behind an OH minus. So it rips the other one apart. Oh, painful. So I got H3O plus. So that one, so one has gained an H plus. And now it's aqueous because it's floating in the water. Now what's left behind? Let's see if you're following. So if I get that for one, what's the other? I guess I could call it the conjugate base. What will be left right here? Can you fill in the blank? I got a water, gets ripped apart. One part becomes H3O plus. The other part becomes what? Thank you. Good. Lots of people typing in. I appreciate it. That is right. Anne-Sophie and Alicia. Exactly. Who is left is the other part, the other piece of the water. And that's OH minus. And that's also going to be aqueous because it's floating around in the rest of the waters. Turns out that happens very little. The K for this is called the KW. And you ready? The K is 1.0 times 10 to the negative 14. Oh, how likely is that to happen? The negative 14th power, man. Pretty unlikely. But it's an important value. We're going to use it over and over and over this year. And it's called the KW. The W, of course, stands for water, doesn't it? And that's at 25 degrees C. Not surprising. At standard temperature, 25 degrees C. Okie dokie? Good. We're going to stop right there. I know I said 9:45, but you actually have another class then. So we're going to stop here at 9:40. And again, write me if you have questions. Try and work through. I know it's hard on your own. I hope to see you March 9th. And thanks for participating, those who did. Okay, we'll see you on Wednesday. Bye-bye.